This video is going to help you with finding the resultant of two vectors. So take this example. We're told that the shape is a parallelogram. That will be important. And we're also told that the ratio of the lengths of O to D to B is 2 to 1. So from here to here is 2 parts, and from here to here is worth 1 part. And that could also be useful to us later. You also need to think about what you know about a parallelogram. So in a parallelogram, we know that opposite sides are of the same length, and we also know that they are parallel to each other. And if you link that to vectors, the important thing about vectors is that they have two vectors which are equal have the same length and the same direction. So therefore I can say that this is also A because it's parallel to OA, and I can say this is also C because it's parallel to OC. So I want to go from O to B. I can't do that directly at the moment because I don't know a route to get from O to B. But I do know that I can go from O to A and then from A to B. And that's useful because I know that O to A is called little a, and I know that A to B is called little c. So that's the answer to part 1. The vector O to B is A plus C. Now I want to go from O to D. Again, I don't know how to go directly from O to D, but I do know how to go from O to B. This is where the ratio comes in. I know that O to D to B is the ratio 2 to 1. So altogether there, I've got 3 parts. So O to D must be 2/3 of the way from O to B. Now you notice in part 1, I've just worked out what O to B is. So that's 2/3 of O to B, which we found out was A plus C. So 2/3 of A plus C. If I expand out that bracket, I get 2/3 of A and 2/3 of C. So now a question I'd like you to have a go at. I'd like you to find me first, please. Find me the vector E to C. And then secondly, find me the vector, E to D. Just a hint, take real care with the direction of your vectors.